briefly explain what the XFELO is used for?
Yeah, XFELO is used for experiments with very narrow bandwidth, so with high spectral purity. So you can generate very high intense X-rays with a very narrow bandwidth. And for certain experiments, this is extremely useful. And we can achieve spectral brightness 100 times higher potentially than at current experiments.
Can you describe the components and their functions?
So, at the heart of the experiment, we have the superconducting accelerator, which delivers highly intense and remarkably stable electrons at a megahertz repetition rate. These electrons then pass through the ondulators, a special magnetic structure, wiggling the electrons and squeezing out X-ray light from its motion. These X-rays then pass through a set of the diamond crystal and mirrors, which reflect and purify the X-rays at a very low losses and guide them back to a second set of crystal and mirrors, forming the X-ray cavity over a distance of 66 meters. Now, then we need the high precision mechanics, because at the next pass, the megahertz repetition rate, we need to hit the electrons, which are the size of a hair, with the photons, also the size of a hair. And for this, we need remarkably high precision on these mechanics.
What is the outcome of this setup?
So we managed to deliver very spectrally pure X-rays with close to no background at all and quite reproducible and stable. Now, because we have so narrow acceptance on the bandwidth, on the wavelengths, we are fixed to that single wavelength. So that's our current outcome.
What are the advantages compared to existing undulators?
So the XFELO has three advantages compared to existing undulators. The first one is that it is shorter. So we have only 4 undulators for the XFELO instead of 35 for regular SARS operation. The second one is that the spectral bandwidth is much narrower, about 100 times than for regular SARS undulators. And the third advantage, and that's maybe the most important one, is that from one pulse to the next pulse, we expect to have almost the same intensity. So we will have a very regular beam, and it's almost like a real laser, and that would be much easier to perform experiments with.